In this video, we will give a brief overview of the reproducibility study we performed on Greenwood et al.'s 2024 original paper, User Item Fairness Trade-offs and Recommendations, and how we extended it. In every recommendation system, there exists an intricate balance. Recommendation systems that just recommend the best fitting item to each user could create unfairness between items, with certain items being never or rarely recommended. On the other hand, algorithms that focus too much on item fairness might negatively impact user performance. The original work focused on this trade-off using a theoretical framework to investigate how user fairness subjected to item fairness is affected by population diversity and incorrect or missing preference data for users. The core principles of the theoretical framework include, firstly, utility matrix omega, which encodes the utility values associated with each user item pair. Each utility value is obtained by taking the cosine similarity of the respective user and item embeddings. And how these embeddings are created, we will see in the next slide. Secondly, there's recommendation policy rho, where rho represents the matrix and rho I specifies the distribution of weights over all items to recommend to user I. The values in rho are obtained by solving a constraint optimization problem that adheres to the principles of egalitarian fairness for users, meaning the goal is to find optimal values in rho by maximizing the minimum user fairness across all users. And the user fairness is denoted as UI here, and the item fairness as IJ. So the thing is, user fairness is constrained by an item fairness constraint, and simultaneously needs to ensure that item fairness remains above a specific threshold gamma of the maximal possible item fairness. For the reproduction of the original work, the same arXiv dataset as in the original work was used, consisting of papers published on arXiv starting from 1991. The dataset was divided into two. Firstly, the train set consisted of computer science papers published before 2020 and were used to create item and user embeddings. And secondly, the test set, which consisted of computer science papers published in 2020, used to create item embeddings of items that can be recommended to users. For both train and test set, all papers are given a paper embedding based on their title, abstract, and categories by feeding this aggregated data into a TF-IDF vectorizer. To create user embeddings, the maximum value over all papers the user wrote in the train set is taken for each index. And finally, the cosine similarity of the embeddings for each user item pair is taken to obtain the utility matrix omega, as we saw in the previous slide. Greenwood et al.'s theoretical hypothesis was that the cost of item fairness would be lower, as items are already more evenly distributed in more heterogeneous preferred groups. They empirically proved this finding, something which we successfully reproduced in these first two plots, where you can see that on the x-axis is the item fairness and on the y-axis is the user fairness. And you can see that the blue line of the more heterogeneous user group is consistently higher than the red line of the homogeneous user group. So as item fairness increases, homogeneous users are more negatively impacted. The second test investigated the effect on users for whom no or incorrect preference data were present. Greenwood et al. Empirically proved that the user fairness for these users was already that low that imposing additional item fairness constraints on them did not further worsen it. And this is a finding we also successfully reproduced. Now we asked the question whether the original findings could be generalized to a more widely used domain beyond the niche academic context. And therefore, we extended the original research by performing the same tests on the novel dataset about books on Amazon. As before, we divided the dataset into a train and test set and performed all remaining steps analogous to the approach in the original paper. The results of both our empirical tests show a similar trend to the results of our reproduction, similarly affirming the claims of the original paper. As all results considered so far only considered a single recommendation for each user, we also asked the question whether the original findings could be generalized to a recommendation framework that recommends multiple items to each user. For this, we generalized the constraint on row I, which was the distribution of weights over items to recommend to user I. Instead of letting row I sum to 1, we generalized the constraint to sum to k. This lets the dot product of row I and omega I become the expected user utility of recommending k items per user I, which relates back to UI here that we saw previously. We found that homogeneous user groups still encounter a higher cost than heterogeneous user groups when imposing item fairness constraints, which can be seen in the plots above by the fact that the red line of the homogeneous user groups is still consistently lower than the blue line of the more heterogeneous user groups. However, the negative impact of item fairness in general is lowered for an increasing k. For higher k, misestimated users are also less impacted. However, this is independent of the item fairness constraint, as still near no impact is observed within each graph when increasing item fairness. So in conclusion, in the reproduction of the original work and both extensions, we observed heterogeneous user groups encounter a lower cost when imposing item fairness constraints compared to more homogeneous user groups. And secondly, misestimated users are little impacted by item fairness constraints. Now, both these observations are in line with the empirical claims and conclusions of the original work, and we therefore conclude that the original work is reproducible and generalizable to a more widely used domain beyond the academic context and recommending multiple items per user. Now, this was just a very brief overview of our reproducibility work. In a full paper, we go much more in depth. So if you got some time, give it a look.